Hey, if you are someone who is looking actively to learn more about Docker and Kubernetes interview questions, and you have recently interview schedule, and you are looking something to prepare, and you are not much aware about what to prepare for Docker and Kubernetes real-time questions, what are the things actually look like when it is deployed in a company, how an application is deployed in a company standard when it is deployed with Docker and Kubernetes, then this video is a must watch for you. So please watch this video till the end. Hello everyone, my name is Pankaj Gupta and I'm a cloud architect with overall of 10 years of experience. I have overall of 6 and more years of experience in Kubernetes and Docker technologies. I'm here to explain you more about Kubernetes and Docker extensive knowledge on interview preparation and showing the real-time scenario-based questions. So in this video, I will be telling you about Docker and Kubernetes with the application deployment and showing you the demo how an application can be deployed in Docker and Kubernetes. So to begin this video, I will categorize this video in two sections. In the first part, I will be discussing more about um, application deployment, because for troubleshooting we just need a sample application. So we will create a sample application from the Docker images, and we will basically create a Docker container. We'll create a Docker image. From that we will push the Docker image to the GitHub or Docker hub, and from there we will pull this image to create our first application pod. Once this is done, we will move ahead to discuss more about the interview questions or the troubleshooting that can be handled with this all infrastructure deployment. So let's begin the first part of the troubleshooting. Here we go. So we have this infrastructure design. I have just created this just to make you understand this is something we are going to prepare. From our local, we will create a sample application and build an image, Docker image. We will post this image to Docker registry repository, which is a Docker hub here. We can even post that Docker image to different targets like GitHub registries or ECR, and then from there we will pull this image based on the credentials, and if it is a private image or not, if it is a public image, these credentials or secrets not required. And then we will create our first application deployment with all part like service, pod, and ingress, etc. This part we will cover in second part, but the first part we will be covering here just to create the first Docker image and deploy create a first Docker container. So before we move ahead, I will really recommend you to watch my previous videos on Docker, which is a Docker real-time project. I just created Docker Part 1, Part 2, where I covered both of the more fundamental basics on real-time project on Docker. So this is Part 2 and this is Part 1. In this part, I have explained more about how Docker deploys an application in your local and more about troubleshooting, and the most important part is the architecture. So with the Docker architecture, you will be seeing like in your local you have a Docker Docker daemon install, Docker CLIs work as a client, and Docker Hub as a repository publish agent. So basically, my recommendation to you is to go through with these videos so that you can better understand how a architecture is involved when we do play with all these Docker commands. So let's move on to the first image creation. So here we will be creating our image, or you can say Docker container, this part with Docker file. We have optionally to create a Docker container or Docker image from that container or from this Docker file by using either by Docker file or from the CLI Docker run command directly. But I would recommend to use Docker file, because in Docker file in industries actually Docker file is the most preferred method, because we have lots of automation or customization that can be written in Docker file. Basically the declarative approach, which is most preferred way when it is about to deploy with the application, deploy the application with CI/CD fashion. So When in Docker file we have the ability to mention all these instructions which we are requiring, and we can even define it variable based, so that we can and anytime want to change certain parameters, that can be done. So it is easy way to handle uh, container image or create a container image with Docker file. So let's move on. We will be creating our sample application with the Docker file. So let's create our Docker file, first Docker file. So by standard, Docker file have a name like Docker file, but if you want to customize the name, you can create a simple these ways of Docker files. You can just give this name, a specific name to Docker file, not necessarily with dot this name, but I'm just giving this name for my convenience. So you can just rename this, and this will be further used to create a Docker image. So first part is to create a Docker file. Let's go ahead. So there are certain parameters to be written here in Docker file, like from, add, copy, run, lots of command, entry point. So these commands are basically used depending on the application design. I'm not going to cover all these parameters here, because the objective of my call is to give you the demonstration on troubleshooting part. Basically, to cover the troubleshooting part that is involved in industrial standard like application deployment, so that we are much more aware about all the small components and parts that is involved in an application deployment, or when an application is deployed in using Kubernetes, then what are the things, what are the parts, what are the segments that we can cover to troubleshoot. So basically, I'm going to just write a simple Docker file here and create my first image. You can say just use Nginx Alpine. You can optionally use any image of your choice, but I'm using here as a Nginx Alpine image for my first web page creation. We can we do have always option to make it more complex depending on our requirement. So I will be mentioning index.html file and the path that should be kept. So when we create a image or we web app using Nginx, the standard path for the index.html file is basically inside user directory. So inside user directory we have a application image path, which is basically uh, wait, inside, yeah, slash user slash share slash nginx slash html and then index.html. So basically this is the standard path, user slash share nginx html, when an simple nginx nginx based web page is created. So what we are doing here is we are using simple base image from nginx with alpine tag, and then index.html that should be there in our local directory where we are running this docker file dot default or any docker file, and this file will be copied to this location inside that container. Once this is done, now we have to create what our first index.html file. We can simply create a very simple index.html file like welcome to my first web page, like that. But I'm for my reference, I'm just giving this the little complex structure like it. I'm defining some heading and giving some colors to so that we can isolate different application which we are going to build from these container images. And once these are created, we will be creating our pods from these images. So once those will be created, we will be able to identify different apps. So basically my objective is to create different applications so that it looks like a standard deployment a company is having when an application is deployed. So in this, I'm not going to explain more about this part. You can pick index.html as per your convenience, but the objective is to simply have a web page where I can just give you a demonstration the difference between number of applications we are going to deploy. So once these two files are created, our next step is to simply create a image like docker. Once this docker file is created and index file is created, our objective is to create a docker image from this. Let's build this image and give a name like app default. I'm giving tagging this image app default. And before to create this, let's firstly see what are the how many numbers of images are there. So currently I'm just running with one image. This is not related. This is running from few 18 months ago. It was created. So and then let's do docker ps. So again there is no new image created, so I have no new recent application created. So let's again review. I have this Docker file created here. Don't bother about these. These are just my existing folders. You just need to focus on these two. Docker file.default and index.html. You just it can be given any name as per your convenience, but the objective is like you should be mentioning this name. So let's give this a name Docker default to the image we are going to create it, and then let's export on port 8080 and hyphen name. Let's give this a name, not name actually. We are just going to pass the docker file. Okay, sorry. This port we are going to mention in when we are going to create a container. So here we are simply going to create a mesh. So this is very simple. Is command docker build hyphen t. It is not mandatory, but we can optionally give a tag to the image, and then file which we are using as a docker file, and then dot. So with this I'm going to basically provision a image. It is going to create an image. For more about what are the actual these commands, you just can refer my previous video as I suggested. So let's do quickly docker images. When I run docker images, you see here it created one image with the latest tag app default, and then I'm going to use this to create a container. So let's clear the screen. I hope this contents are visible. Let me set this view to settings, text size. Let me make it 24. So let's just open it in a new terminal. Okay, I think this would be much better. So let's run docker images to show this is the recent image created. Now from this existing image I am going to create a docker container. So to run a docker container, just run docker run command, and with this run command I am going to pass -d option to run this container in a detached mode, so that we have this terminal free, and that we can use further to fire some further commands. -p I'm using to export the ports from my image, from my container basically to outside world. So from an inside to outside, it's run opening at port 80, and then app default, just give a name app default to this container. I have hyphen name parameter by this, and the name of image. So name of image is app default basically. So let's just give, it has given a ID docker ps. Now you will see here docker ps has created one container. This one is the recent container, and this container just created few seconds back, and this is having image name this one, container ID this one. We can just optionally do some like inspect command to inspect more with the container ID. It will show you what are the inside things in with this container, like what are the configuration use. Nginx is defined here, it's running the Nginx with if it is having OM kill or not. So these are the basic raw data inside the container. Again, to when suppose you have a container created, docker ps, you can see this container with the docker ps command. If you go want if you want to go inside that container and then run docker exec hyphen it and then container id or name and just a simple shell or maybe the bash environment, maybe you just don't need to pass this. So by this, by running docker exec hyphen it is for interactive terminal, and the docker container id or name, and the shell you have to pass because you have to tell docker that you're going to launch on a specific shell of this docker container when you're going inside that container. So that's too simple, ls hyphen lrth, or maybe just go to the var log directory and see nginx logs created here. So if you see here, there should be two file basically created by the definition or the configuration of nginx. When it's configured nginx, uh, it creates by default these two logs file. So we can see these logs coming out. So we just created one container here. To access this container, go to the local, and from local just run localhost and on port 80. So you just see we have this web page appearing because of our index.html based on this nginx part created, and we are seeing just this page. And once we do some like click on this one, the logs must be getting generated here. So do this way, maybe here. Okay, so this is basically second part we will be reviewing later on, like why these logs are not appearing. This is very good thing to catch here. So, but from outside container, like we can just simply docker do docker logs and the container ID, this one, docker logs and this one. So we see here the logs are appearing. Basically these logs would be coming in the var log error.access log file, and from there actually it's getting reflected outside this container. So with the docker log, docker inspect command, we can do more operations like this. So basically, let's quickly recap. What we have done is we have just created one Docker image from the Docker file .default. Index.html file was the file used for creating a simple web page like this. Let me quickly review what it looks like again. Index.html. So it's having my first web page, light blue color, like you see here, and then it's having a button, change content. When you click on the button, it will change content to hello, you are landed to default page. Just do this like that. Yeah, here change content, click on me, refresh, click, you are landed to default page. Okay, and then yeah, closing bracket of this change content, fine. So you can just customize this like that. I'm going to create two more containers. So let's go ahead to create two more container like that, red and one blue. So for that we also will be needing two more docker file and index.html file. Okay, fine. I'm going to create one more container, two more container basically. So from another second container, I'm going to use again the same Nginx Alpine. This is basically optional. It depends on the user what kind of application is or on which image application is based on. So Nginx Alpine, I'm this time going to expose on port, let's say 5001. And then copy. I'm going to since use red.html. I'm going to create my user second container as a app red, so that it is displays in the web page with 5001 port, a red page. I will show you like why I'm using this. User share, and then uh, yeah, it was nginx slash html, and then index.html. So basically, again, this is the default path of index.html. We have to pass this file from our local host where we have this docker file dot read again copied from this to this default folder inside the container. So this is done. Let's go out outside it and then create again red.html. So you just need to copy the content of the default or index.html and then simply replace the color from light blue to red or wherever it is you want to apply for the button or other content. So I just simply copied the same index.html file and changed some content here. I'm not going to give more brief into about it, but because it's just basic index.html. So for now again we have second docker file created and index.html file, which is red.html file here. So docker again, just to build it, we need docker build -t tag. Let's say this time there app red and then hyphen file name like this and dot. Once we execute it, it will create another image which is having the tag app red. You must have noticed that it has not taken much time because the nginx alpine image is already installed in the system because we already created this image. So it has already pulled this image to the local from where actually is going to pull the image. So what actually happens in the background is where when we fire this docker build command, Docker CLI receives our input, which is a Docker client, and pass this instruction to Docker daemon, which is running as a Docker engine in our system, in my system, and then it receives the instruction from Docker CLI. Docker CLI will pass this like user want to create a image. Now the Docker daemon will read this instruction and will try to work on that. So it will try to find that image. It will not see the image first time here, and then it will go to Docker Hub. To go to Docker Hub and pull the image, it needs a Docker credentials install. So when you fire this command at first time, it may show you like some error related to that like this image is not present. I mean this is not connected. So you have to first log in to that Docker registry or Docker Hub. So you have to first log in. At first, you have to log into your registry so that you are able to pull or push image to this Docker Hub. So basically, it at first it will give error at your end because you might not be connected to Docker Hub or the registry where you want to pull or push the image, from where you want to pull the image or to where you want to push the image. So at first you may have to run this Docker login or the destination that login that you are using to pull or push the image basically. Again, in there are lots of ways to log in, like there's a credentials way. When you do Docker login, you have one way to authentication is you just pass the username and password. Another way, it is succeed. It has not asked anything on my side because the reason is from my Docker Hub. This is my Docker Hub. I have this my user this one. So when you are running this first time Docker login, it will ask this username and the password for this username. Another way is you can just create a token, Docker token, get that access token, and then just pass this to Docker JSON file. There's a Docker JSON file. Yeah, token C, these files are there basically. So basically I will suggest you to use any of the method but not to export in anywhere of the file. Okay, So once this login part is done, we will be able to pull a push image. Now again, move on to the second image. Let's see if it was created. We have created the second image. Now the next task is to run this, run a container. Again, I'm using -d for detached mode so that I am having this terminal free and it is running as a daemon process in the background. -d and -p. Let's export this time port as a 5001 because I am going to use a different port to export on this. So from outside world it will be available on 5001 and inside is 80. And then just name this container app red, let's say, and the image name app red. So this has again created a container docker ps. It's the same container created docker ps. Let's say docker logs. So nothing as of now. Let's go to the terminal window. Localhost run on 5001. So it has created a blue container. I don't know why it's created a blue. Let's dig on this. Why? Cat in cat red.html. Because we have used this. Well, we have used this correct file but wrong name. Okay, no hurries. I think let's just do this again. Let's just move this red.html file and okay, let's just clear this out. Docker ps. I'm going to kill this container because it's wrongly created. I have used actually the index.html code of blue, but it has created a red. So just clear this out. I kill this container, and now I have to remove this image as well. Docker system prone -a-m. I'm using this command, but I would not recommend you to use this command. This is very important command. I will show you later on the importance of this command. So a quick brief, like this command is basically going to prune, basically remove all these unused container volume or images with -f force and for all. Basically, if you don't want to use all, just pass like images, docker or volume, whatever you want to remove. So since why I'm using this command, because if I run docker ps, I do not have that container we just removed running, but in images it is there. I just, so basically I want to remove this image rmi, but it is going to give error. The reason is because it is running as a, it is occupied still by unused container, dangling container, which is in exited mode, is not running anymore, but it is used. So I will do docker system prune -a-app. It will remove all these unused images container which is not running. So as you see, it has not affected our running container. It's very good command to troubleshoot or clear the space of the node where our docker is running, so that it is not going to fill quickly, because it happens most of the time. It is the usual practice of docker that it is having all these unused container images and volume available in the same system, and that's why it's using more resources of system, cpu and memory, and it's quickly piling it up. It's just filling it up very fast. So docker now run docker images. So you see that it has not even removed those existing image that is already used. So it has not touched anything which is already running. So by user docker system prune -f, we are good to remove unused containers, volumes and images to clear out the space as well as unwanted images to overlap. Like now I can again build an image. Before we build, let's move red.html to blue.html, and then default create another red.html. So I am going to use now this time a correct file, red.html. Don't worry about that. This is not. If you refresh it, it has already gone. No, because we just killed the container. So this is my correct red.html file. Previously I copied blue.html actually, and referring again to docker.red, dockerfile.red. We don't need to update anything here because it's already using the correct. Now again we have to build. So this is a something we have to like run again and again when we are going to bring any changes. So this is a challenge when we have to update our existing running container. Then we have to clear that container, kill that container, and again have to create that image, and then again have to create that container from that new image. So this is the only way to update the, or you can patch the container, but this will be ease out in Kubernetes. This is a very good benefit, like a demonstration where we can like define the Kubernetes is good to handle these kind of things. So basically it helps in patching. So again let's create again app red, and that's app red. So it's going to create the image. Let's say images. It has created again the image. Again from this image I'm going to run this container um, with hyphen docker run hyphen d hyphen p 5180 hyphen name. Okay, this is all good. Clear the screen. Docker ps. So it has created a container. Now refresh the page at 5001. Now it is red. You see, it is fine. So now let's quickly create another one. We all already have a blue.html. We just don't need to do any changes here. We only need to copy the container of docker red.s dot docker file dot red to docker blue red, and just change here simply the port to expose 5002, and then this file and copy what we are copying. Again build a container. Make sure you use the same docker file and use the same tag of this image blue. It has created an image again. Let's see this docker images. Okay, you have docker blue, docker default, docker red. All these three images recently created. It's of same size because we have used the same base image, which is Nginx Alpine. You see in the output we see the tag latest blah 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 stuff. So now we are going to create a docker container from this existing image here. Here now we are going to use this blue as a with the container name, and then 80 exported to 5002 outside. Now here let's say if you don't want to give a image name, you can simply give image id for blue, like that. It's optional. So it has created again docker ps like this. But the thing is here, the image is saying here when you are running docker container, the difference is it has used this container id as, or sorry, image id as the tag image name, the one you have used it. So basically this is something I intentionally pass so that you can understand the difference on these parts, like it's having container id and what are the image names. So image name is basically the one we just pass here, so that image should be existing actually. Again images, it should be existing actually. So if you pass even image id or name, doesn't matter, image name, but in the output you will see if you pass image id it will show the image name as image id, else it will show the name as the one you have just mentioned here as the image name. So again now we have docker ps 3 container running. Let's see another open another terminal. Oh no, 5002 port. So Basically, a quick recap: we have created three container: default, blue, red, and blue. My objective was to create these three different container is to give you a demonstration so that I can relate something which is already running in industries, like how industry deploy an application. It's not too easy. Just it's not like a simple application based on index.html. There's lots of complexity like there's a Java image or CSS code. Lots of code is there that we can use later on in our next further demos. I will show you my complex application, that is a front end or back end application, maybe running a website, complete website which is having front end, back end, and database. But at this point of time, I'm using this simple image to just demonstrate to make you understand the component of Kubernetes that will be used for troubleshooting or the how this is mapped internally actually. So we have three sample application basically like an industry, and these sample applications are having different web pages, so we can optimize it to basically use more complex code. We can display instead of index.html we can use a lamp server, php server, or we can display this content as a javascript based content. It depends on our requirement or our complexity of the code, but as a demo it is good for now. Like we have three applications container running. So what we have done for is we have just created a sample application with simple index.html file and push. Now we are going to push these images to Docker registry. Like I said earlier, I should be connected to Docker registry, Docker hub. It should not be Docker registry only here. It should not be hub.docker on. It can be any destination, like it can be GitHub registry or Elastic Container Registry from AWS or Azure etc, Azure registry, or maybe Google registry. So it depends on our requirement or system design or company's decision, like where to keep these custom or private images. If they want to keep it as a private images, usually that is the preferred way, or the public images. So now I'm going to list these images and push these images to Docker Hub. Before I post these images, let's tag these images Docker tag this like each individual images so that we can identify. This is the default syntax. I have to use my user name here for tagging. I'm simply using it. It's not mandatory for tagging. Like let's use blue. I just pick blues one, app blue, and then app slash blue. We can just give latest also here, latest, or just maybe app blue, depends on. Let's make it app blue, so that we are not too much confused. And then same way, um, Docker, I'm going to tag this image, second image, and let's tag it to app red, and then this app red. Again, the third one, command C, and then image name. I have not copied. Make sure you copy it very correctly. Okay, and then it is going to be the default page, app default. So it's tagged. Now the next task is to push these images. Docker push. So simply copy this Docker push and the image tag name. I will show you this. This is image name. We just retagged and then tag latest tag, and then here is going to push these images to somewhere. All these images, yeah. Again, the same way. Let's say red. app red. So it's saying layer already exists. The reason in my GitHub repository this image is already existing, but it will create another layer of this. If you see layer, it will create another tag. A few seconds ago, it will create another tag. Like a few seconds ago, you see it was post. So that is a good thing in Docker, like it maintains the versioning. So if you see here, you will be able to identify like addition SHA is the same one as used here. Here, this one. This is the same SHA 95 blah 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 956 blah blah blah. This is the same SHA that is we can use to compare. Okay, blah 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 is the SHA and this is the latest tag. Okay. In the same way, let's say default. So what we are in the meantime is running. Let me show you here. So basically, we have just created a container image and we are going to push it to the Docker repository. And in next part of the video, which is going to be part 2 of the troubleshooting of this video, we will be going to create this part, basically a deploy an application. Okay. So Docker images, let's say Docker images. So we have these new images. The good thing to compare here is when I given a tag here, Docker tag here, it has created a new image basically, but not container Docker PS. Containers are still running and it has been not affected. The image ID is all the same that was previously used. This one. But when we, as soon as we tag these images, it has created a duplicate images. This is good to understand. And since these images are not getting used and we have already pushed these images, we can use these images to remove basically. So let's try. It's not an image basically. Let's try to remove this tag basically simply. Now why it's saying is because it is not neither an image name or nor a tag. So basically we just need a image ID. But here image ID is same for these. So my objective to show you here is as soon as we create a tag with the new tag here, this is the tag section, this is the repository section. It do create a same image with same image ID and it is not being used currently in any container. Okay, so this is a safe way to push an image so that we are not touching the image. Even we touch the same image, it doesn't make any effect. Let's try to run this push command without a tag like this one. I'm just trying to show you if does it really works or what error it gives actually. So if I do this way, it is giving error. Why? App blue image is not existing. App blue comment, but we are not touching here. You see? So basically it needs a destination. That's why in the repository section it is having my repository name updated. It should be either my repository. Now try this way. PG3391. It works, I think. Tag does not exist. So it's saying a blue tag does not exist. Now when we have used this name. So basically when we pass this name, this time it is going to this image app and this repository name. It finds this is the repository I am going to use, but it is not having this tag. It is we have passed latest tag. So That is the difference. That is the difference I try to show you. When we use a new tag, we pass a repository name, and the importance of repository name is with the repository name only it understand. Okay, now Docker Hub or Docker daemon have to work to push this image to this repository and with this tag. So that is the importance of passing this username here with the repository before the repository. I hope you got it. I will say to play around with these stuff. These are very important things, and these are ask an interview. Now, before I move on to the second part of this video, which is where we will be deploying this application, the next part is to basically provision a sample Kubernetes cluster. So there are various ways to provision a Kubernetes cluster. we can uh, we can create either by Terraform, we can by create by EKS or GCP. I mean GCP has or its own like GKS or Azure KS, AKS or Kubernetes by like kubeadm, kubespray. But these are actually the one which are used in is industry standard. But here I'm giving you as a demo. So I'm going to create a simple Minikube cluster. With the Minikube cluster, I will be able to create a simple single pod or maybe multiple pod, depend on the parameter passed. With that, I will be able to help you understand like how we can deploy an application. So the Docker part is done. Now we understood the importance of images. Why we need images? So basically, once this Docker part is done, you don't need a Docker anymore here. You only need images. So but when you are going to play around with the Docker Kubernetes, you just need images. Now the question is, can you run the Kubernetes in different location? Yes, we can have our cluster running in different location. Maybe we in our local we run all the Docker part, or we have the Docker part Kubernetes this first part run executed. Now we want to have the Kubernetes in different location. So this is actually the standard scenario. So it is not necessary when a user is running this pushing these images, it's on the same location where the Kubernetes is running. So the major thing is we can push these images from our local or from somewhere else location to the Docker center hub repository or ECR. But the importance is this should be available remotely, and it can be picked anywhere in any location where our Kubernetes is running. In this demo, I will be using this Kubernetes installation in the same system where my Docker is running. But the importance is wherever the Kubernetes part is running, it also have a Docker already installed, because you will be able to provision um, pods and all things because of Docker only. The reason is Kubernetes is using Docker as a runtime. If you see the standard documentation of Kubernetes, Kubernetes uses the Docker as a runtime. So to create a container inside pod, it needs actually a Docker. So as soon as we provision a Kubernetes cluster anywhere in any location, doesn't matter in the same system, it also have a Docker container. Docker actually, you see Docker only. So there only then we can create a pod and inside that all the resources. Fine. This part is done. To go ahead with the next part, let me provision a Minikube simply. Minikube. Let's see the status, current status. I already have maybe Minikube running. So there is a command I will be showing you, giving you. I will pass this repository. I have this all this stuff written over here in my first app, create ingress repository, with the even the question interview questions on each part. So if I demonstrated about Docker file, so it has all maximum parameters like what is the from, maintainer, label, run, all these parameters that are maximum, and we can define inside our Docker file. So I have defined somewhere here. This is important in interviews, like people ask in interviews or what are the maximum or what are the parameters that you have worked on to define in the Docker file. And in the next part, let's say Docker file have questions. This is earlier about the Docker parameters, and this is like having all the questions, maximum questions on the Docker file. I have just mentioned here. I will be keep updating as soon as it strikes my mind. So I will keep updating. This is the very important question difference between CMD and entry point and copy and add instruction. These all things. This is the maximum question that can be covered in an interview. And next on, when I will be doing the second part, Kubernetes cluster, I will be adding here all these questions based on this. So in ready-made, you will be getting all these questions from here that should be asked in interview. And I think these are the maximum things that can be covered in an interview. If you know all these stuff, I'm sure you're going to rock the interview. Basically, so these all instructions are written over here. Whatever I have just discussed, just do a quick recap. I discussed all this part, the first part. These all questions and code is available in my repo. I will give this repo reference in my YouTube description. You can find from there and clone in your local and do the operations. And now I'm going to provision this. I already this Minikube cluster running, but I will be giving some commands here to start the Minikube cluster. I have not passed here, but I will do here. Let's how to start a Minikube cluster. I will update this Docker file. I mean this README file. So this part is done. Now in the next part, we will be going to discuss the second part, like creating our pods and resources and what are the difference in these resources, like in this part. This is very important part. That's the reason I have used the different three applications, because I will be demonstrating more about ingress and the real-time scenario and the questions that appear in an interview related to API etc. Fine. So this is something I will be going to discuss in the next class. So I hope this is fine with this one. If you have any questions, do trigger in the comment section, or you can raise in my repository reply somewhere here. If you know, you can fork this repository. And last but not the least, okay, I hope this is covering all the part. In quick recap, I just created a simple Docker image and I posted to the registry, nothing else. In this part, lots of troubleshooting questions appear that I have already tried to update in the question section of repository. You can refer from there. Hope this lecture find you well. I will see you in the next class of this troubleshooting part 2. Bye for now.